When you deploy your Python applications in Linux-based servers, whether it is a mobile application or web application or data engineering application, you have to deal with underlying operating system. Python provides several libraries to deal with them. We will be seeing a couple of them which can be leveraged to interact with the underlying operating system, either to run the commands or to access the environment variables. Python provides several libraries which can be used to run. However, OS and Subprocess are most popular ones. We can import the libraries such as OS and Subprocess before start using them. There are a bunch of commands to create directories, change ownership, change permission, run general system commands, etc. All those can be taken care using Subprocess. OS library is extensively used to read environment variables at runtime of the application. It is used to pass keys, credentials to work with the database, external applications, etc. Typically, keys and credentials should not be part of the source code. One way to deal with the keys and credentials is by creating as environment variables on the underlying server on which the applications will be deployed. Using OS, we should be able to access those environment variables. So let's start with OS here, then we'll actually get into Subprocess, which can be used to run the commands and also to process the output. We'll see a couple of examples about how to process the output of Subprocess also when we get into the details related to Subprocess. The way you can import OS is, you just have to say import OS. You don't need to install any third-party libraries to use either OS or Subprocess. You just have to directly import like this. Then if you want to get current working directory, you can actually say get CWD. CWD stands for current working directory only. You should be able to get the details about what is the current working directory in my case. You can also read environment variables by using a special attribute called as environ, which is available on top of OS, which exposes an API called as get. As part of the get, you can actually pass the environment variable name and you will get the corresponding value here. So you can actually check the path value here. Another classic environment variable is nothing but user, which will actually give us the details about which user is used to log in. You can see the details here. I have used itversity to log in onto this system. And the environment variable is nothing but hostname. You should be able to get the details about the hostname also. I think hostname is not a valid one. I think it's host, not the hostname. Let me check. Even this one is not returning anything. If you are not sure about these things, what you can do, using Jupyter, you can actually use shell magic and you can run this command called as env. It will give us all the environment variables which are available right now. You can leverage these things to print whatever is part of these environment variables. When it comes to host, there should be an environment variable. I think it is not explicitly set in my environment for whatever reason. If it is CentOS, I think it will be available. As the underlying operating system is Ubuntu, it is not showing up here probably. That could be the case. Another classic example can be home directory. You can actually say home like this and you should be able to get the home directory details using this os.environ. If you look at the get function on environ, it also takes the default value. So in this case, I can say os.environ.get to get the help on this. You can see here, it takes two arguments. The first one is key, second one is default. So if the key doesn't exist, whatever is set as part of the default, that will be returned. So the way you can leverage the second one is, earlier when we use hostname, we could not get any output, or probably we might have password. Password might be set or might not be set. If it is not set, you might want to print something which is default for the applications that are running. You can actually set that using get at runtime like this. So we can say os.environ get password. As of now, it is not set. You can set by saying like this. Passwords should be confidential. As it is not set, when we run this, it will actually print the default value. Even for hostname, you can give a try to get whatever information we want by passing the hostname as the first argument. So this is the significance of OS and the functions like get, which are exposed via attributes like environ on top of OS. There are quite a few other things. You can explore those things as and when it is required. You can just say os dot and hit a tab. It will list all the functions that are available. On top of accessing environment variables, you can also change the ownership of the folders, change the permissions on the folder, etc. using OS, and you should be able to take care of whatever you want to within these limited options. However, to execute the commands using underlying operating system, Subprocess is more popular compared to OS. OS is widely used to get the environment variables. Subprocess can be used to actually run the commands themselves. Let's get into the Subprocess now. So in this case, we'll be running ls-ltr command to get list of files in the current directory. Let's import Subprocess. If you want to review the output of ls-ltr Linux command, you can actually use shell magic like this and you can see the output here. Now, if you want to pass and process the output, there is a function called as check output. You have to use this. There is also a function called as check call. You can also use that. Whether you use check call or check output, you have to pass the Linux command as a list like this. So in this case, we are passing the command as list. And this list contain two values. The first one is ls. Second one is whatever we have after space. If you want to add more arguments to it, and if you want to pass those things as part of this check output call, you just have to add more elements to this list. Then it will work without any issues. So that being said, let us look at the output of check call first. We can invoke check call also to get the output of ls-ltr. And if you look at the output here, let's see what the output contain. It contain only the exit code, whether it is successful or not. In this case, it is successful. That is why we are getting 0. So for commands where you just want to create something, such as create a folder or create a file, so on and so forth, you can use check call. However, if the command returns some output and if you want to process that output, then you should be using check_output. So these two are the functions which we use on top of subprocess quite widely. So if I use check output in place of check call and run the same ls-ltr command and see the output of output, you can see that you got the binary output. Okay, you can decode it to string using the decode function that is available on top of this object. We can actually check the type of this object by saying type of output. It is of type bytes or binary. If you want to decode to string, you can actually use decode function with UTF-8 like this. It will convert to regular strings. If it is a natural language characters other than English, then probably you might have to change this argument to a different value. For English, you can actually use this. Now I should be able to run this, and you should be able to see the output as string. There is no B at the beginning. You can also get the type by invoking the type function on top of this output.decode with UTF-8. It is of type string. As it is converted to string, we should be able to use a function called as splitlines, which is available on top of string, chooses the line break and convert the string to list of strings. So you can actually review the output by just saying output.decode of UTF-8 splitlines like this. Let's review the output. It have returned the list. You can see all the elements are in the square brackets and they are comma separated, which means it is of type list. You can also say type here, and you should be able to validate the type of this object. It is of type list, and each element in that list is of type string. Don't worry too much about these things if you don't understand it at this time. When you go through the collections, you will be able to grasp the concepts behind the lists and split lines and so forth. We'll be using these things quite widely once we cover basics of collections at a later point in time. For now, if I just wanted to print each and every line that is there as part of the ls-ltr output, I just have to say for recin, then the output.decode.splitlines, which will give us the list of strings. We are iterating through them and we are printing each and every entry in that list one at a time. You can see the output. The output exactly look like the output of the ls-ltr which we have seen earlier. Now, as this is now Python object, we should be able to process leveraging the skills that we are going to acquire once we go to the collections and process the way we want. In this case, let's say I want to get all those files which are greater than 12 KB, similar to what we have here. Then I just have to extract this information and try to compare with 12 KB, and we should be able to see only this entry. Like that, you can process the way we want depending upon your business requirements. However, at this time, the primary focus is on OS and subprocess to deal with operating system level tasks as and when it is required as part of our application development process. Make sure you are comfortable with the relevance of OS and subprocess, and also make sure you practice few things about how to leverage those to get the information we are looking for. We have to use these things when we actually get into the application development process quite extensively.